Hello, everyone. I'm Jin Jiayi from Shopee team. It's my great honor to be here. Today, the topic of my sharing is the integration of SeaTunnel and Druid in Shopee. Before that, here is a quick introduction to myself. Besides being the team leader of the Shopee Druid group, I'm also the committer and the PMC of the Druid and the teacher for the league time. And there is a personal blog, One, that I maintained it for nearly 10 years. In addition, I'm also one of the Apache SeaTunnel contributors. I have contributed 106 pull requests and 17.8 pull request has been merged into master branch. Concurrently, the number of contributions is ranked 7th in the SeaTunnel open source community. Mainly includes contributed connectors for Druid, InfluxDB, and IoTDB. Realize the future of automatically generating lessons, which reduce the access threshold for users, and also fixed many bugs and made lots of improvements and extra. My sharing is divided into 8 chapters. The first part is basic concept. Let's take a look at what those components are. SeaTunnel is a data integration platform to help business to quickly build up pipelines. Flink is a stream process engine, and Druid is a time series database. Okay, let's take a deep look at what Druid is. Druid is a high-performance real-time analytical database. It seems that every database is labeled high performance, otherwise no one will use it, right? But we still need to explain ourselves. So how does Druid achieve high performance? The main points are column storage, bitmap inverted index, data compression, SIMD, cache system, etc. Druid's Lambda architecture also enables it to support real-time data writing and querying. At the same time as the OLAP engine, Druid also has a rich set of query operators built in to meet a wide ranging requirements. Actually, Druid is a mixture of time series database, data warehouse, and search system. Because the data stored by Druid is a time series type, so Druid supports related functions such as per aggregation, downsampling, etc. And Druid can ingest event data to support decision analysis. We can treat it as a real-time data warehouse. Also, Druid can perform structured query for no series dates and supports functions such as searching, grouping, filtering, and etc. Which means you can query Druid without any time-stable information, such as start time and end time conditions. Well, after we got a first peek of Druid, let's take a look at the major features of Druid. First is column storage and inverted index to speed up queries, support online streaming and offline batch ingestion, and Druid can handle flexible schema, even the schemas. And Druid can partition data from the time dimension to speed up time series queries. And support Circle. You can access Druid through HTTP or JDBC and pre-store or Trino. And the Druid can easily scale in and scale out. Last but not least, Druid can automatically load balancing to reduce the workload of the maintenance. Next, let's take a quick look at Druid's business scenarios, including the clickstream analytical to get the path of the activities of users, risk analyze to ensure the security of the system, network performance monitoring, and the server metrics storage to keep the high quality of the service. And also, Druid can be used to support supply chain, analyze APM, BI, and OLAP. Druid has a huge community and supports a large number of claims, including Python, JavaScript, Ruby, R, PHP, Crucial, Scala, Java, Coside, Presto, Chino, and etc. Next, let me introduce Druid's data model. Since Druid is a time series database, all queries and the indexing process in Druid are related to the time dimension. And Druid uses milliseconds to save data, the time stable date. As you can see, by default, the time is displayed in ISO 8601 format. Second part is dimension. Dimension column can be char, number, or other complex types. Dimension column can be used to filter and group data. The third part is metrics. Metrics column can be number, which is used for aggregation and calculation operations. In Druid, whole table is divided into trunk by time dimension. In trunk, data is divided into one or more smaller files, aka segments. Each segment is an exclusive file, usually contains millions of records. Druid also has a super important concept, which is wrap. In the left table, there are 10 row records. In the right table, there are only 3 per-graded records after wrap. The wrap strategy shown in this slide is day level. The data of the same day with the same timeline are rolled up together, and the metrics column has been summed up as well. In this way, not only a large amount of storage space can be saved, but also the query performance can be improved. Okay, that's all for the basic concept. I believe that at this point, everyone already knows those components very well. Next, let's take a look at the my process. For normal users, we downloaded the SeaTunnel release file and unzip it, and then monitor the config file for the specific business scenarios. Next, we started the my class and keep an eye on it until it's done. For engine, we will clone the code of the SeaTunnel project and apply it, and also update the config file and start the my class in the console or IDE. Yeah. Before we go further, there are some related keywords about Druid you might need to be aware. Router provides Unity API network management and web UI. Broker is usually a query model that we are familiar with. Mid manager will manage the tasks assigned by upload, and historical stores all the data according to the coordinator's instruction. For the Druid Sync connector, after the task is submitted to Druid, uploader will create the node in the Zookeeper. Mid manager will receive the new task event from Zookeeper and create a PM to process it with a JVM application. After the task is done, the Z node will be created for new task status, and overload will be noticed through the Zookeeper event as well. At this time point, you may wonder how the data flow within Druid. Okay, so let me show you more details about it. In Druid, after the segment file has been created, Mid Manager will push it into deep storage and record the metadata information in metadata storage. Usually, deep storage is HDFS or H3, and metadata storage is PostgreSQL or MySQL. After that, coordinator will per segment metadata information from metadata storage and create the node to track the watch in the historical node. Next, historical will pull segment file from deep storage and record the location information in the zookeeper as well. Okay, for Druid source connector, SeaTunnel will send a HTTP request to broker as a client, and the broker will get the location information of segment from zookeeper. Next, we'll split the query into sub-queries and read new data from the mid-manager nodes and query all the data from the historical nodes. And then merge those requests and return it to the SeaTunnel. Okay, let's quick start it. First, we need to complete the code column to our development environment and compile it. Next, we should run the local link example to quick verify the environment is okay. Also, we can open the debug model to better understand the generate operation process. At the end, we still need to learn the grammar of the HO COM through the back to console config file. So how can we custom the plugin for special business scenarios? At the beginning, we should be clear about the type of the data source, process engine, and plugin type. And then we create a sub-model for your customer plugin. Next, we imply APIs such as Flink Batch Sync or Flink Stream Sync. Of course, the API may be renamed in the new version of SeaTunnel in future. After that, we need to settle down the configurations and maintain the map types. Kindly remind here, the open stream should be closed at time. Next, we must record a new plugin into meta-info service directory. After that, it will better to create the related document for this new plugin. At the same time, we should complete the functional verification. First step, we can use Docker Compose to quick start a Druid service by follow-up commands. And the next step, we need to update the config file, which named as application.conf under the config dictionary. In this config file, the source part is fixed source stream, which will generate records and send them into the SeaTunnel. The transform part is default value, so that we will not process any operation here. The sync part is Druid sync, which contains the URL of coordinator and the name of data source for the local Druid service. By this command, we can start the whole pipeline of the SeaTunnel. Next, we can open the root page by this command and input the select star from middle one circle. And click the run button here. And then you will get the results and finally completed the verification. Okay, let me briefly introduce how to contribute your code. Normally, we should create the issue first and ensure the code style and then let the lessons file are correct. Next, submit the pull request and link the issue in the description of the pull request and check the status of the CI after a period of time and follow up comments and continue to improve it as well. Okay, next, let's take a look at those business scenarios in Shopee. The first one previously stored data in Hive, but they need a sub-second query latency to serve their end users better. So they want to migrate the data from Hive to Druid. Usually, we will access business to export the data from the Hive into HDFS, and then Druid will create ingestion tasks to read those HDFS files. But SeaTunnel can quickly build up this pipeline to reduce the workload. By the way, the data hub here is our internal name for the SeaTunnel. This is another one I want to share with you. Ordinary business store data in InfluxDB, but the standalone version of it couldn't meet the requirements of stability. But also the secondary development for the distribution version of InfluxDB will consume a lot of manpower. So this business switched the database from InfluxDB to Druid and want to dump the old data into Druid as well. Normally, we need a developer the Flink program to process the upstream data in Kafka and send them back to the another Kafka topic. SeaTunnel can directly read the data from upstream Kafka and write them into Druid, which is better way for this business scenario. Well, finally, let's make a summary. In this sharing, we learned some basic concepts about SeaTunnel, Flink, and Druid, and we mastered mine processes. Now we are familiar with the quick start of SeaTunnel and how to customize the SeaTunnel connector by itself. Also, we understand some business scenarios in Shopee and figured out how to complete. Yeah, let's continue. Also, we understand some business scenarios in Shopee and figured out how to complete the functional verification and how to contribute the code to the open source community for the SeaTunnel. Okay, that's all I want to share. Thank you for listening, and I hope my sharing can be helpful to you. Thank you.